Okay, this video is about forced vibrations. Forced vibrations is an application of second-order linear non-homogeneous equation, like equation 1. Okay, so and equation 1, remember, is associated with the system here. Okay, here you have a mechanical spring, and this is the natural length here. When you hand some weight, then they stretch the spring to the length of L. Okay, then they achieve its equilibrium position. We let u equal to 0. U here is a displacement, okay, and u going down is a positive direction. Under this setting, we got equation 1. So for the different problems, what do you need to do? Just find m, gamma, k, and ft. Then you get your equation. Okay. Now let's look at the example. A mass weigh 4 pounds, stretch a spring 1.5 inch. Then the mass is given a positive displacement of 2 inch from equilibrium position and released with no initial conditions, assuming that there is no damping force and that the mass is acted on an external force of 2 cosine 3t pounds. Formulate the initial value problems. Describe the motion of the mass. As I said, you don't worry about the equation. All the equation will be like, for this mechanical vibration, it's like equation 1. You need to do, just find m, gamma, and k. Okay. Here and f. Here is easy to find the gamma. Okay. They told us that there's no damping force. It means the gamma is 0. And they also tell us ft. External force is 2 cosine 3t. Okay. And also, we can find m easily. M there is, they said, a mass weighing 4 pounds. That means Fg equal to 4. Therefore, your m here is 4 divided by 32, which is 2 over 16. Okay. Wait, 2 over 8. No, yeah, it's 1 over 8. Okay, simplify this, give you 1 over 8. Alright. One more thing we need to find is a k. Okay. Remember, at the equilibrium position, mg equal to k times L. Okay. At the equilibrium position, restoring force is k times L. They stretch the spring from its natural length by the L inch, whatever. And mg is a gravitational force. Those two forces are equal. You get an equilibrium position. So this means mg here is 4 times k times L. L is, they told us L there is a 1.5 inch. 1.5 inch is 1 over 8 foot. Okay. Therefore, we got a k here equal to 32. Okay. Alright, now we have our equation. M here is 1 over 8. U double prime, and gamma is 0 plus 32 U equal to k equal to 32. Okay, equal to external force, which is 2 cosine 3t. Okay. Now let's simplify this equation by multiplying 8 on both sides. We got u double prime plus 256 u equal to 16 cosine 3t. Okay. So we get a second order linear non-homogeneous equation. We want to solve that. Also, we need to find the initial condition. Okay. So 1t equal to 0, they told us positive displacement, which is 2 inch, which is 1/6 foot. Okay. And they told us there's no initial velocity, which means your initial velocity is 0. So now we set up our initial value problem completely. Okay. Next, we need to solve this initial value problem. Okay. So this equation is a linear non-homogeneous equation. Remember, what we need to do is what? The general solution will be like this. C1U1 plus C2U2 plus capital U sub t. Okay. Now, let's find U1, U2 first. U1, U2, there are solutions for this equation, 256U, corresponding homogeneous equation. So what do you need to do? You just need to find its auxiliary characteristic equation. 256 equal to 0. So your R here is a positive and negative 16i. Okay. So we got a U1 here equal to cosine 16t. U2 here is sine 16t. Okay. So next, we need to find this particular specific solution. Again, capital UT is not really something specific, just a solution. Okay. So now let's find this specific solution by using undetermined coefficient method. Okay. Okay, now let's look at our equation. The right hand side is cosine 3t. Therefore, the function we need to try is a cosine 3t plus b sine 3t. So we need to find a and b such that u sub t is the solution. Capital U sub t is the solution of this one. Okay. So now let's determine the coefficient. What do we need to do? Take a derivative. Okay. So take a derivative once give you negative 3a sine 3t plus 3b cosine 3t. Okay, take derivative again because we're going to put it back in the equation. So they give you negative 9a cosine 3t and then minus 9b sine 3t. Okay, we put it back in the equation. Okay. So we got a capital U double prime, which is negative 9a cosine 3t minus 9b sine 3t, then plus 256 capital U, which is a cosine 3t plus b sine 3t. Okay, we want to capital U is a solution, so they give us the right hand side, which is 16 cosine 3t. Okay. Now, let's put all the term with the cosine 3t together. They gave you 256 subtracted 9. They give you 247 a cosine t, cosine 3t, okay. Then minus 247 b sine 3t equal to 16 cosine 3t, okay. The right hand side, there's no sine 3t, therefore b must be 0, okay. And to make the left hand side equal to the right hand side, then your 247a should equal to 16, right? Okay. So therefore our a here is 16 over 247. Alright, so we find our capital U. Okay. We find our particular solution, which is (16 over 247 cosine 3t). Okay. Therefore, our general solution is C1 U1. U1 here is cosine 16t plus C2 sine 16t, then plus the specific solution cosine 3t. Okay. See, you find the capital U, right? This one is a solution of that differential equation. However, this one does not satisfy your initial condition. That's why we still need to find a general solution. Okay. Now, we can determine C1 and C2 by using our initial conditions. For example, okay, so we need to take a derivative of U. Okay. If you take a derivative of U, you got C1. Okay, you got negative 16C1 sine 16t, right? Then plus 16C2 cosine 16t. Okay. Then minus 3 times 16 over 247 sine 3t. Okay. Okay, we know U prime 0 give you 0. Okay. But look at the right hand side here. Let t equal to 0. Okay. T equal to 0, then sine 0 is 0. So the first thing is 0, then cosine 0 give you 1. So you got 16C2 times 1. Cosine 0 is 1. Okay. Then sine 0 is 0. Therefore, we got this. So this implies you got 16C2 equal to 0. Okay. Therefore, your C2 equal to 0. Okay, therefore your U here is equal to C1 cosine 16t plus 16 over 247 cosine 3t. Okay. Now, then you let t equal to 0. Okay. U0 equal to 1 over 6. That's our initial condition here. Okay. So, and in this equation, let t equal to 0. Cosine 0 give you 1. So you got to C1. Okay. C1 times 1. And the plus 16 over 247 cosine 0, let t equal to 0. Give you another 1. Okay, so your C1 here equal to 1 over 6 subtract 16 over 247, which gives you 151 over 1428. Okay, finally we find our displacement function. Is the C1 is that, which is 151 over 1428 cosine 16t plus 16 over 247 cosine 3t. Okay. So finally we're done. So this one, u here, this u here give you displacement. If you give me time, I can tell you that u value would give you where is that block. If u is negative, that means that block is above equilibrium position, which is here u equal to 0. If u is positive, that means that block is below the equilibrium position. Okay, so again, once you see the word problems, don't be panic. What do you need to do? The equation is always equation 1. You just need to find m, gamma, k, and ft. Once you find those things and the initial conditions, after you find those informations, the rest of the things is how to solve the equations which we learned before.